In this unit, we will introduce you to programming languages and their features, simple program construction, main components of a program, Turbo C integrated development environment, and writing programs in C language.
After completing this unit, you must be able to use suitable programming language to write programs, construct a simple program, identify main components of a program, use Turbo C integrated environment to write, save, compile, and execute programs.
We have already discussed programming languages and their types in Unit 5. Now we will discuss some features of each programming language. The lowest level of computer language is the machine language. The instructions of machine language comprise of zeros, ones, or sequence of zeros and ones. The instructions written in machine language do not require a translator or a compiler to convert codes, and their processing is fast. The difficulties in using machine languages are memorizing codes and memory addresses, finding errors in programs, and their machine-dependent nature. The next level of computer languages is high-level languages. The purpose of these languages was to enable programmers to write code in their native language like English. Translators and compilers are required to translate programs written in high-level languages into machine language. These allow you to divide a program into small reusable routines called functions or procedures. Some high-level languages include Fortran, COBOL, BASIC, Pascal, C language, Prolog, RPG, Lisp, and Java.
Fourth-generation languages allow end users to extract information from a data source. The user only specifies the output and the code is automatically generated by the language application software. Modern database applications come with query generators to produce output by automatically writing the queries.
Visual programming replaces text-based instructions with the graphical components that include buttons, combo boxes, and rectangles. Integrated development environments enable programmers to write complex software easily. Program debugging is simpler. Visual development environments include Visual Basic Integrated Development Environment and Boolean Turbo C Integrated Development Environment. Natural languages enable computer to accept instructions in the form of natural languages like English. At present, computers can accept and recognize different languages.
A computer is a general-purpose machine that can solve an infinite variety of problems. However, the problem-solving capability of a computer is entirely dependent on the human ability to develop efficient algorithms. An algorithm represents logical steps to solve a problem. Computer program development involves a series of activities. Broadly, these activities include problem analysis, logic design, pseudocode design, coding, debugging, testing, and implementation. Problem analysis involves understanding the problem. A simple problem can be addition of two numbers. Logic design aims at developing the algorithm to solve the problem. The problem can be divided into small modules that perform independent functions. For example, a typical problem may be divided into separate modules to get input validate data, make computations, and generate output. The modular approach is also called structured programming. The programming logic is symbolically represented by flowcharts. The flowchart shows the sequence of steps to solve the problem. It shows symbols to represent the start of program, initialization of variables for input and result, addition process, and output. Pseudocode expresses the programming steps in ordinary language. Plain English sentences are used to express input-output statements. For example, start the addition program. Create memory locations called variables to hold two numbers. Create a variable to hold the result. Get input from user. Perform addition and print the result. Coding involves translation of pseudocode into a computer language. It may look like this in C language. The program may contain some errors or bugs, and the process of identifying and removing the bugs is called debugging. Two types of errors are syntax errors and logical errors. Syntax errors occur due to violation of grammatical rules of the computer languages. The computer lists these errors during program compilation or translation. Logical errors represent errors in logic that solves the problem. Logical errors are difficult to point out by the machine. To check any inconsistency, the program is repeatedly tested with different set of data. If the output is incorrect, the logical steps are revised. When the program is error-free, it is ready for implementation.
Computer programs differ in size, scope, complexity, and their application. Regardless of their function, these comprise of these components: declaration statements, input and output statements, arithmetic statements, logical operations, control statements, repetition control structures, and reusable subroutines. Declaration statements are used to declare variables and constants. Computer languages provide special words for declaration statements. These are called keywords and have specific meaning for the compiler software. For example, C language provides int keyword to declare integer variables that can hold whole numbers. The declaration statement may look like this: int keyword followed by the name of variable terminated by a semicolon. Input statements are used to enter data during computer program execution. It identifies the source of input and the memory location where the input is saved. Languages use words like get, input, and scan to receive input. For example, C language uses scanf statement to get the input using keyboard. A typical input statement in C language may look like this. We will discuss these statements when we learn to write a program. Output statements transfer the results of operations to output devices. Languages use verbs like print and display for this purpose. For example, C language uses printf statement to display the output on monitor. A typical output statement may look like this: Arithmetic operations include multiplication, division, addition, and subtraction. Computer languages use mathematical symbols for arithmetic operations. These C statements declare a variable to hold the result of addition. The result is then stored in the variable sum. Logical statements are used to compare numeric and non-numeric values. Logical operations include to test whether a value is equal to, less than, or greater than another value. These statements compare two numbers. The expression evaluates to true because 5 is greater than 2. Control statements allow you to execute a set of statements based on a logical decision. Computer languages provide if structure, if-then-else structure, nested if structures, and case structures for this purpose. You can use logical expressions in control statements. For example, the expression A is greater than B can be used in control statements like this. In addition, languages also provide repetition control structures that include while, do-while, and for structures. These will be discussed in another course. Modern programming languages also allow dividing programs into small routines called functions and procedures. These perform specific tasks. Functions are reusable program components.
So far, we have learnt the technique of basic program construction and components of a computer program. Now, we will learn to write some programs in C language. We will use Turbo C Integrated Development Environment to write and execute our programs. Turbo C version 3 is a DOS-based application. When you execute Turbo C, the main screen may look like this. It is placed inside a window. You can press Alt, Enter key to maximize it. In Windows environment, you won't be able to use mouse, and we will use keyboard shortcut keys for different actions. To create a new C program, choose File menu, select New, and press Enter to create a new file. The name of file will be provided by the application automatically. Before writing a program, it is important to specify the file locations. These locations will be used during program compilation. If some required file is not found in the specified locations, an error message is displayed. To specify the directories, select Options, choose the Directories menu. Here, 4 input boxes are provided. The first box specifies the folder where the files required during program linking and compilation are stored. The second box specifies the folder where the required libraries are available. Libraries are files that contain different functions. These are used during program construction. The Output Directories box specifies the location where the object file, backup files, and executable files will be stored. Here we specify the folder where we want to save our files. For example, C folder on D hard drive. Source directory specifies the location for additional libraries. Here, we specify the C folder on D drive. Select OK by using Tab key and press Enter. Now, we are ready to write our first program.
Now we will discuss the construction of this program. The first line of my first program starts with the void word. Void is a keyword. It has special meaning for C compiler. It is followed by a main function followed by empty parentheses. These parentheses represent the main is a function. Every C program must contain main function. The curly braces at second and third line represent the block of main function. It may contain many C statements. Alt F9 key is used to compile the program in this environment. You can also select Compile menu. Select Compile and press Enter key to compile your program. A small window appears that shows compilation information. Success message is shown if the program successfully compiles. Note that total number of lines that are compiled is 3. Press any key to continue.
The next program prints a welcome message. It contains a C statement that prints the message. Printf is a function because it is followed by a set of parentheses. These parentheses enclose a message inside double quotes. A function may or may not take arguments. In this program, main function does not take an argument, while printf function takes an argument. If you compile this program, it will generate an error message that is function printf should have a prototype. The prototypes or definitions of built-in functions are defined in a library file that is available in the include folder that you specified earlier. To include the library that contains prototype of printf function, you must use include directive before the main function. It starts with a number sign followed by include directive followed by a file name enclosed in double quotes. The file stdio.h contains prototypes of commonly used input-output functions. It contains the definition of printf function. When you compile this program, it shows compilation of 312 lines. But the actual code has only 5 lines. This is because the compiler includes additional lines for compilation. Include directive includes lines of code from stdio.h for compilation. Compiler also adds some other information that is required to compile and execute this program.